Okay, this podcast is about how to draw the graph of y equals tangent theta and y equals cotangent theta. We're going to start with tangent theta, and you remember from the UVR definition of tangent theta that tangent theta is v over u. So what I'm going to do, u, there. Okay, what I'm going to do is I'm going to look at the unit circle and we're going to kind of go around and think about the u and v coordinates for some of the points. Notice that I don't have all of the special angles on this unit circle that I drew here. And think about what v over u is. So we're going to start here at 0 degrees. So the coordinates of the point here are 1, 0. So that's saying that v is 0 and u is 1. So v divided by u is going to be 0 divided by 1, which is 0. Okay, so what that tells me is that the point 0 degrees, 0 is on the graph of tangent. Super. Okay, let's continue. At 45 degrees here, the coordinates are root 2 over 2, root 2 over 2. And anything divided by itself is 1, so tangent is 1. So at 45 degrees, the tangent graph is at 1. Let's go and go backwards a little bit and do the same thing for negative 45 degrees here. So negative 45 degrees has the coordinates root 2 over 2, negative root 2 over 2, right? So if I do, uh, positive root 2 over 2 over itself is 1, but a negative divided by a positive is negative 1. So v over u here is negative 1. Okay. And then let's look at 90 and negative 90. At 90 degrees, the coordinates are 0, 1. So if I do v over u, I get 1 over 0, which we know is undefined. And the same thing happens down here at negative 90 degrees. This is 0, negative 1. And if I do negative 1 over 0, that's undefined also. Okay, so let's think about what's going on here. We already have, some clues based on what we did with the secant and cosecant graphs before. It's probably going to be true. These are vertical asymptotes, just like they were when I had divided by 0 in secant and cosecant. But let's try to think through it a little bit more. If I think about an angle that's like really close to 90 degrees, like 89 degrees here, right? What I'm going to get is that v is close to 1 and that u is a small decimal. Oops, decimal. Right? So if I do something that's about 1 divided by something that's real small, what I'm going to get is something that's real big. Right? So it should be true that as I get closer and closer and closer to 90 degrees, my tangent value gets bigger and bigger and bigger without bound. And that's exactly what happens. I get this vertical asymptote here. And if I go backwards towards negative 90 degrees, I get the same thing, except for instead of getting something real small divided by, or something close to 1 divided by something that's real small, I'm going to get something that's close to negative 1 divided by something that's real small. So this is real big, but also negative. So as I go to negative 90, right, I get an asymptote going down. Okay. So now this section between these two asymptotes, what I'm going to call, this is like the fundamental shape of the tangent graph. I'm going to call this a sweep. That's a technical term. But what the tangent graph really is a set of swoops, right? If I look from negative 90 to 90, right, I get kind of the same pattern repeated again as I look from, say, 90 to 270, because what happens if I look at this angle here, like 91 degrees, right? What happens here is I get something that's close to 1, again, divided by something that's real small and negative, right? So I get the same thing where I'm going to get something that's negative and really big, right? So it's going to be coming down here from negative infinity. And then at 135 degrees, the coordinates of my point are negative root 2 over 2, root 2 over 2. When I divide those, I get negative 1. Okay, so that's not equal to negative 1, but you see what I'm saying. So at 135 degrees, tangent is equal to negative 1. At 180, the coordinates of the point are negative 1, 0. 0 divided by negative 1 is equal to 0. At 225, the coordinates are negative root 2 over 2, negative root 2 over 2, and negative divided by a negative is a positive, so the v over u ratio is plus 1. and then at 270, it's undefined again. So I get this swoop pattern repeated again. I find this not so easy to draw, so I like to start at the point at y equals 0 and go to either side, as opposed to trying to draw it as one big line. So I see this pattern, it's repeated twice. That's what's going to keep happening. The distance here, right, is 180 degrees between 90 and 270, between negative 90 and 90. So every 180 degrees, I'm going to get this pattern repeated. So to the right, what I'm going to do is I'm going to draw the vertical asymptote. I'm going to draw the 3 critical points. In the middle, it's at 0. It's at 1 here and negative 1. Then I'm going to connect the dots. Okay, and I'm just going to put the last 2 points on here. So 180, 1 goes up, and then at 540, negative 1 goes down. Okay, so one of the things I want you to think about is if I look at the tangent graph here, the natural period, right? So if I think about how much of this graph do I need to repeat in order to go do, reconstruct the entire graph, it's only 180 degrees. So the natural period of tangent, is 180 degrees, not 360 like it was for sine and cosine and secant and cosecant. It takes 180 degrees to get through a pattern of tangent and not 360. And if I think about the unit circle, it kind of makes sense, right? Because as I go around from 0, right, here tangent's positive, here's tangent's negative, here tangent's positive, here tangent's negative, right? So I see that every 180 degrees I kind of complete the cycle, as opposed to needing 360 degrees to figure out what's going on. We'll talk about that a little bit more in depth later on in this class, but for now, that's all we're going to say about tangent. Let's look at cotangent, and we can go pretty fast with cotangent because we already did tangent. So remember, cotangent is u over v, right? So if I think about the unit circle, I'm going to get asymptotes where v is equal to 0. And I'm going to get zeros when u is equal to 0. Okay, so when is v equal to 0? V is the vertical component, so that happens at 0, 180, and then coterminal angles with those. So I know my vertical asymptotes are going to be here at 0, at 180, at 360, at 540, at negative 180. Okay, so those are not the same places where I had asymptotes for tangent. Those are the, it's shifted 90 degrees to the side. I also know that I'm going to get zeros when u is equal to 0. When's u equal to 0? Well, when I'm along this axis, right? When I'm here at 90 degrees or 270 or any of those coterminal angles. So I know I'm going to get zeros here at 90, 270, 450, negative 90. Now, you might think that I can just draw the swoops in like I did for tangent, just because I know what tangent looks like. It's going to look the same here, but it's actually a little bit more tricky than that. Let's try and figure out what goes on here between 0 and 180 degrees. So here at 45 degrees, right, the coordinates are root 2 over 2, root 2 over 2. When I divide those, I get positive 1. Oh, okay. And then at 135 degrees, cotangent is going to be negative 1. So I still get this swoop shape, but it's going to be backwards from a tangent, right? It's going to come from the top on the left and go to the bottom on the right. And then I'm going to get this pattern repeated over and over again for cotangent. Let's go ahead and put those other critical points on. Okay, draw the lines. Oops, that was kind of a crazy arrow. I kind of missed on that one, but you get the idea. Okay, so draw a big dot there to cover up the fact that I missed. So this is the shape of cotangent. So one of the ways that I like to remember to draw which one is cotangent, which one is tangent, is I like to think about this space here that corresponds to the first quadrant of the graph, right? I know that in the first quadrant everything is positive, so that means that all 4 graphs, or all 6 graphs, sine, cosine, tangent, cotangent, secant, cosecant, everything's positive in the part of the graph that's corresponding to the first quadrant. So if I think about where the asymptotes go, and then I remember that the first quadrant's always positive, then naturally I'm going to get the right shape for cotangent, it's going to go down, and also the right shape for tangent, it's going to go up. Okay, that's all there is to know about tangent and cotangent.